Hi everybody, here's Christian from Teamwork Cast. Welcome to our another episode of Pico-8 Hero. And so today we are going to continue working on our Breakout clone. Let me fix something here. There we go. Just wanted to disable one aspect here. Cool. So I actually spent some time in between the episodes now to test some things out, because there is a slight of a problem that we're going to encounter today. I noticed last week one of my students had the same problem, and sadly I haven't really found a solution for this. Let me explain you what I mean. So this is the version that we left off last time around, and we can actually remove sticky paddle from our goals. Today we're going to deal with angle control. I think this is like a very important feature for any kind of like paddle-based game like Pong or Breakout. You want to be able to control the paddle of the ball, because otherwise the game always plays out the same. The ball will always, reflect the same way. You want to give players some kind of way to influence the direction in which the ball is moving at. Right. Here we slightly encounter a bit of an issue here. I'm going to explain to you what I mean. Because we're going to move the ball at different speeds now, right? So this is here where we serve our ball, and we're moving it at 1 pixel per frame in each direction. And if you run this, it's really nice. Everything is perfect. So let me just put comma values in here. It's still the same angle. We haven't even changed the angle. We're going to change the angle, of course, now. We're going to have to work with comma values. So I put like a comma value here. We haven't changed the angle. It's just a comma value. I'm going to run this. Oops. And you can see it's kind of shaking. It's kind of jittering. Don't really see this on the 30 frames per second, but you can totally see this in 60 frames per second. So I'm going to write some other values in here. It doesn't look as smooth as it looked when it was just 1-1. What's the reason for this? What exactly is the reason for this, right? So let me show you something. I did like an experiment. I was trying to get down to the bottom of this. So let us play this in slow-mo. In order to do this, just a short experiment. In order to do this, we're going to turn the sticky, the moment we did the sticky, we're going to turn this from BTNP to just BTN, because the way we're going to do the slow-mo, it's going to be very difficult to trigger this. And we're just going to go here over to the init, and then we're going to go slow-mo. We're going to create a new variable called slow-mo. We're going to start at 0. And here, when we call update game in our update 60 function, we are going to go slow-mo equals slow-mo plus 1 if slow-mo equals 60, then we update the game and we reset slow-mo to 0. Now our game is going to be, oops, there's something, oh yeah, see, I made the same mistake I was talking about. So in an if statement, you cannot just write one equal sign, you have to write double equal sign, because we're not assigning, we're comparing. Not sure what the problem is. Did I misspell something? Oh, there we go. No. There's a nil value. Slow-mo, slow-mo, slow-mo. Maybe we need to start slow-mo outside of any init function. Does that work? Huh. That is weird. Slow-mo, slow-mo. It doesn't want me to do math with slow-mo. Why? This is not what I wanted. Let me do like a really stupid slow-mo equals nil, then slow mo equals 1, 0. Now I'm really surprised. Oops. Ah, there we go. No. Let me just call it slow. I think I just misspelled something. I'm not. Ah, I think I got it. Slow-mo 0. There we go. That was. The zeros and the O's in this game look very similar. So let me remove this. We don't need this anymore. Slow mo. There we go. Okay. So you can see it's moving. And sometimes there's a break. See? Now it stops for a second. Now it moves. It's moving in this very erratic, like a stepwise fashion. Now it stops a little bit. So the problem is because we have comma values. Those comma values sometimes lead to a situation where you add something to your X position or Y position, and it's not enough to push you over to the next pixel. So then for one frame, the ball stays. Or for example, you would have X and Y out of sync. So you would have a situation where you move X 1 pixel above, for example, but not in the Y direction. So it would like look like this jittery motion. It's generally just not just a smooth movement. It's due to rounding errors, due to the fact that we have to stick to individual pixels. We cannot draw the ball between pixels. And there is just no way. You can also sometimes see when you draw lines in like paint or something, you can draw lines, you get like these jagged edges because there's just no way to make like a straight, smooth diagonal on a square grid like here. Not too bad of an issue. It doesn't look as bad if you move the ball slowly, quickly. It moves bad. It looks bad if you move it quickly, slowly. It's getting late. All right. So we want to move the ball a little bit quicker, and we're gonna have to get used to the fact that it might not look as smooth as it looked before. Okay, not too bad. Let me run this to make sure that it's still moving. Yeah, you can see that it's a bit of a jittery motion. Just something to be aware of. If you have a good solution for this problem, let me know. Maybe this is just something I stumbled across. Maybe there is some kind of good solution workaround in Pico. Maybe there's a good rounding function. Maybe there's certain comma values where it works really nicely. If you have them, let me know because I need them. Okay. So serve ball, this is where we were at. So we want to return to 1, 1. Right, so let us now think about gameplay. I tried one attempt, one solution. There's generally like 2 attempts we can try. One is checking which part of the ball, which part of the pedal we are hitting. And depending on which part of the pedal we're hitting, we're going to change the angle of the ball. That's one solution. Another solution here would be to when the ball hits the pedal, to check if the pedal is moving. And if the pedal is moving one direction, you kind of flatten the angle in the direction the ball is moving. I tested the second variant and I liked it. So I think I'm going to do that variant. I think this is the variant from LOA on Game Boy, which I think was a really good adaptation of Breakout. So let me also explain something how we're going to do the angles, because you might be thinking, oh, maybe we're going to do like sinus and sine and cosine and stuff like that. And I thought we're going to use a much simpler approach here. Let me show you real quick. I'm going to activate paint. So here are the angles I want to have. I want to have a ball that just has just a couple of angles it's flying at. It's not like smoothly calculating the angles and stuff like that. It just has a bunch of angles it chooses from it. It kind of sticks to certain angles. So currently we have this angle. We have like 45 degrees. This is currently our angle. We can go 45 degrees That's 45 degrees. In this direction, we can go 45 degrees in this direction. These are currently our angles. So what I want to add is something in between here. So something like this, in the same direction, something like this, and something like this. These are the angles, the new angles I want to add. You know, to exemplify, these are going to be green. Something like in between 90 degrees and 45 degrees. So these are the new angles that we want to add. And what we want to do is, like, if we notice that the pad is moving in one direction and the angle is flattened, then it just jumps straight down from 45 degrees to whatever is next down, whatever is the next one down, so to speak. Okay. Good. Right. So let me try to pull this off. Let me think about this. I actually have some values in here that I wrote down, which I think work well for our angle. So here are some values. I'm going to put them in here as a comment. So 1, 1 is one good value, and these are two values that we're going to work with. This is going to be the second angle. This is going to be, if x is if x is 0.5, then this is going to be the high angles, and if x is 1.30, that's going to be the low angles, the flat angles. Okay. I want to create a new variable that tracks which of these angles we are at. And so my idea would be that, let me explain it real quick. So this is going to be, oops, let me give you a bigger font. Can we have a bigger font, please? Yeah. Okay, so this is going to be number 1. This is going to be angle number 1. This is going to be 0. This is going to be 2. This is 2 as well. This is 1. This is 0. Right? So we're going to start at 1. So ball ang equals 1. Just so we save in a ball angle. And then I want to have a function that changes the angle of the ball. That whatever the ball is, whatever direction the ball is flying at, I just want to change the direction at which it's flying at. So I'm going to call this function set ang. And then it requires an ang. And I'm going to actually go like, in this moment, I'm going to go ball ang equals ang. So it actually changes also the ang value, the ball ang value. Okay, so we're going to check what ang we're talking about. If ang equals, now double equals 2, then something happens. Else if ang equals 0, then something happens. And I'm going to have an else just in case we end up, for some kind of bug reason, we end up putting a 3, for example, inside, or like a -1. In those cases, we want to just make sure that there's something we're going to do about this. And in this case, all of the other cases, we're just going to reset the ball to 1, 1. Now, if I put the ball 1, 1 just in here, there's a bit of an issue because we're just resetting the direction of the ball. What if, so if I was going to say 1, 1, what if the ball was actually flying in this direction? Then it actually changes completely the direction it was flying at. So we kind of want to preserve the sign of each of the two values. We want to maybe change the value. So we want to change, for example, the speed at which it's moving in the y or x direction. But the general direction of if it's going up or down, we're going to preserve that. And usually programming language have a good function for this called the sine function. Lua doesn't have the sine function. So we're going to write ourselves a sine function. It's going to be a very easy, simple function. That function will just return the sine of a number. And, you know, I could like write a little formula with, you know, with absolute and stuff like that, but whatever. I'm just going to do like a simple if statement because we're not going to execute this set angle function too often anyway. So we're going to go like if n is equal than 0, then else if n is greater than 0, then else and else is going to be, that's going to be 0. Return, that's going to be, if it's greater than 0, we're going to return 1. And if it's smaller than 0, we're going to return -1. So it basically returns a -1 when the number is negative, a 1 when it's positive, and a 0 when it's 0. It's just the sign of whatever number we're giving it. And then we have like a very simple solution here, where we go here, ball x, dx and dy is going to be 1 times sine of whatever was the direction, the sine of the dx previously. So we preserve the sine of our speed, but we change the amount of our speed. So that way the ball won't just flip over and fly in completely different directions. It will preserve its general trajectory, but just change the trajectory slightly. Okay, and the same thing we can now do to the other things, the other situations here where angle 0, that's going to be the flat angles. So we're moving slower than 1 in the y direction and faster in the x direction. You might be asking, how did I derive at these values? I basically took a sine and cosine function and put in 12.5 degrees, and then I rounded a little bit, so we have like a slightly rounder values. So we don't have like, because you get like 0.1 something, and I just cut off some decimal numbers. So it's not perfectly the same speed, but it's close. Right, so it's moving fast in the x direction, slow in the y direction. This is what we wanted. And then we do the same thing for the 2, but now we reverse the speeds. So we want to have it move fast in the x direction, but slow in the fast in the y direction, slow in the x direction. Easy. Easy. Okay, so we can theoretically, if you want to, we can now change the angle. But now we need to add the situation where we actually do change the angle. And so we have to scroll down where we want to do this when the ball collides with a pad. Check if ball hit pad. This is where we want to be. Now there's a bunch of stuff going on here, but let me put some comments here. Let me be a good programmer and put some comments in here. So when we come back to this later on, we know what's happening. So ball hit paddle on the side. This is, we're not going to change the trajectory of the ball when this happens, because that means it's kind of bounce off the side, so it's changing direction anyway. We're not going to mess it up at this point. But here we're interested in ball hit paddle on the top / bottom. And then this is bottom. And this is top. The top is what we're interested in. This is where we're going to actually deal with different angles. When it hits somehow it hits the pedal on the bottom, we're going to lose the ball in a second anyway. So we don't really care about this, but we do care very much about what's happened now. So first yeah, okay, this is good. We're resetting the position of the ball. Just want to make sure. We're resetting the position of the ball on the top of the pad. And then we're going to go, yeah, we're going to now check at what speed the pad is moving at. The problem is the pad can be moving in two directions. So this is where this is the maximum speed that pad could be moving at, 2.5. So we're going to take this. And there's another cool function that's kind of like the reverse of the sine function. The sine function that we just written is a function that just returns the sine and nothing else. The reverse function is a function that returns just the value of a number. Wait a minute, did I just say the sine of a function? A sine function is a function that removes the sine of a number and nothing else. The reverse function, so to speak, is a function that that returns the value of a number without the sign. So if something is -5, it returns 5. If something is 5, it still returns 5. It's always positive, no matter if it's what kind of sign it had previously. So we can use this to check if our pad is moving fast enough, because we don't want this to trigger always. We only want this to trigger when the pad is really moving fast. We want to see if the player is really trying to change the trajectory of the ball, if it's really trying to move the pad as the ball hits the pad. So we're going to go like this, if, and now this is a function that is actually part of Lua. So this is ABS, absolute, pad dx. So this is the absolute speed, and we know it's the maximum is 2.5. So if this is greater than 2, let's say this is greater than 2, then, and then end. And so here we now change angle. So now we have to think about how to deal with this. This is a bit of an issue. So if the pad is moving the same direction, if the pad is moving in the same direction that the ball is moving at, if it's kind of like moving with the ball, then we want to flatten the angle. It makes sense. We're kind of giving the ball more vertical speed, horizontal speed. We're giving the ball more horizontal speed. It's moving faster in whatever direction it's moving at. So how are we going to check for this, right? Well, we can still use our sine function. So we're going to go like if sine pad dx equals sine ball dx, then. So basically, if this horizontal speed of our ball has the same sign as the horizontal speed of the pad, it means that they're both moving at the same speed, same direction. So flatten angle. And then else is, how is the opposite of sharpen angle? Doesn't seem right. Doesn't seem the right way to spell this out. Let's call it a lob. It's you raise angle. Let's go with raise angle. Okay. So how are we going to actually deal with those things? Well, when you flatten angle, it's very easy actually. So we're gonna go do set angle. That's the function that we had previously. Ball underscore ang -1. We're gonna flatten the angle, right? It's gonna be, when it's 1, it's gonna be 0. But there's a bit of an issue here. So when it's 0, it will be -1, and then that's gonna be an error. There is no -1 in our function. So we're gonna use again this little beautiful function that's called mid, and we're gonna make sure it's between 0 and 2. So whatever ball ang was, whatever ball ang is after, we subtract 1 from it. It's never going to be falling below 0, and it's never be above 2 as well. I explained it previously, but basically, just to reiterate real quickly, the mid function, it takes 3 values, and whatever is the middle value from the 3, the one that's not the highest and not the lowest value, that's the one that it returns. So yeah, it's an easy way to make sure that a value is between 2 different values. Right, and then we can take the same function here and we get plug in here. But this time around we're raising the angle, so we're going to add +1. Easy, right? Let's save this and see if this works. So there's a problem here. Set angle. I think the function might be not actually called set angle. I think we call it something else. Set ang. Look at me being all silly. So let's go sec ang. Oh, already the gameplays work. So now we have a high angle. That's nice. I'm gonna try to flatten the angle out. Yeah, we flatten it a little bit out. Oh. See, it's working because I'm trying to. Okay, now I sharpen the angle again, or raise the angle. I'm gonna flat. I want to see the flat angle now. Okay, sharpen again. I'm losing my own game. There we go. Now we have a low angle. So this is good. We have some really good control here. Something I wanted to add as well is what happens if we raise the angle and the angle's already raised. It would be kind of nice if you could actually reverse the direction in which the ball is flying. Not really sure if this is physically correct, but whatever. I think it would be kind of nice. So when we raise the angle and we're gonna go like if ball underscore ang is raised, we're already at the second angle, then and else we're gonna set angle. So if it's already raised, we're actually gonna continue having a raised angle, but we're gonna just I'm gonna reverse the x direction. So we're gonna go ball dx equals ball dx minus ball dx. So we're gonna just flip the sign of the direction at which is moving the ball, but we're not gonna change the angle. Now this is a bit difficult to achieve, to be honest. Like now we're getting into like pro gaming territory here. Yeah, now I pull it off, so it worked. But yeah, we have a really cool game at our hands. You can have really nice ball control here. You can have pull off some really nice strategies, and especially now that was nice because now the ball actually ricocheted of a vertical wall we constructed there. Good. So this is it. This is our function. This is getting a bit complicated, but we're almost there. If you look at our goals, there's not too much left. We want to do the combos now, we want to do the levels and stuff like that, but things are getting there. So this is going it for this episode. If you have any questions, post them in the comment section. If you ever get a good solution for this jittering problem, because I was really trying to solve it, I was really trying to make it smooth, but I think this is something that is inherent to Pico-8. So if you have a good solution there, let me know. Otherwise, we're gonna continue next time around with, so the angle control is solved. Next time around, we're gonna do the combos. So we have some really nice bonuses going on when a player manages to hit multiple bricks between hitting the paddle of the ball. See you next time around, guys. Bye bye.